In this video, I want to do a managerial economics problem. This is not an economic lecture by any means, but it's just a taste of how you can think about using Microsoft Excel to address a managerial economics problem, and where we're always trying to figure out the quantity to produce, where the price that you're going to sell is going to be a function of the quantity, and we're trying to either maximize a profit or maximize a revenue. So again, it is not an economics, but it's just looking how you can address this. You can certainly use calculus to find optimal answers, and the very last example that I focus on is calculus based, which has very little to do with Excel. But the first two examples are good Microsoft Excel applications. So just to start with some terminology, the question is always what should be the quantity that we're going to produce, and the price that we're going to sell it is going to be a function of the quantity. And then the total cost is the cost of producing everything. So we've got two definitions, the marginal cost and the marginal revenue. And the marginal cost is what the change in the cost, the total cost, as a function of quantity. And the revenue is the change in the revenue as a function of quantity. The total revenue is what you generate once you establish a quantity that will control price. Price times quantity is what the revenue will be. You'll learn in your economic classes that if you want to maximize profit, we set these two derivatives, or the marginal cost and the marginal revenue, equal to each other, and we solve for the best Q. If you just want to solve for the best revenue, you can set the revenue equal to 0 and solve for Q. So let's put some numbers to this to make it a little bit easier. So we'll start, and let's say the price that we can sell something for is 500 times 4Q. So if you look at how that would work, is that when you don't make very many things, if Q is really small and there's a limited number of Qs, then you can charge a lot for that. But when the ordered quantity, or with the price, the quantity is high, your price drops down. And then also the total cost is a function of how much you make. And there's always, there's a fixed cost in this case. You start out without making anything, just the act of making anything, you incur a cost of 20, and then there's a variable cost at 6 times whatever your quantity is. So how do you maximize profit? What should Q be to maximize profit or revenue? Well, one way you can do this is just plot these functions. So here's my Q, and I'm starting at 20 because I've done the problem. I know roughly what the boundaries are, and I've plotted or generated a table all the way up to Q to 100. So if we look at the price formula, the formula for that is 500 minus 4 times whatever Q is. So I can generate the price that I would charge as a function of quantity. And then the total revenue is P times Q. So it's going to be the price, which is a function of Q, times Q to get a revenue. I can also get a total cost as a function of quantity. And then my profit is my revenue minus my cost. So if you look at revenue or my profit as a function of quantity, and also my profit and revenue, you can see that you get this quadratic equation, or this where we have a unimodal, and you can see if we're trying to maximize either one of these, it looks like the best answer is somewhere a little past 60, 61, 62. So somewhere around here. If I'm trying to maximize, it looks like it's around 62 for profit. For revenue, it might be a little bit higher. Okay, that's just classic Excel, plotting a graph and looking for the highest value. Well, there's a faster way. There's another way to get there, and this works good when you have a hard time plotting things. So the same principle, these are the formulas we just talked about, but now we're going to use Solver. Solver is an add-in to Excel. If you go under File, Options, look at Add-ins. If you select the Solver add-in, then under Data, Solver, a form pops up, and it is a form that allows you to establish, well, what am I trying to make really big or small? What am I trying to optimize? In this, I'm trying to optimize my profit. That's why I've selected cell F120. In this case, I only have one cell that I'm changing, and that's my Q, cell B20. And I want the model to find this to make this as big as possible. So when I hit Solve, it says Solver found the solution. And look what it did. It changed Q, which was originally 20, to 61.75, and that maximizes that, which is the same answer as what we got when we plotted. Same answer that we got when we plotted. We plotted whole numbers, but you can see it's close enough. Yeah. Now that's fantastic. So these first two solutions are how you can use Excel to solve economic problems. Again, what a quantity should be in terms of what we should produce. This last one is calculus, and I'm not going to try to teach you calculus in a 2 or 3 minute video here. I'm just going to give you the taste of what happens. These are derivatives, these marginal cost and marginal revenue, and when you set them equal to each other, then you can solve for Q. So how did I get the marginal cost and the marginal revenue? Well, they're derivatives. That was how we started, and they're derivatives. How do I calculate a derivative? The example that this one is based on that we're going to use is we're using the power rule. So if I have a function y as a function of x raised to a certain power, like x squared, then the derivative of y is, so this is what the terminology, derivative of y with respect to x would be, you bring the exponent in front of the x, and then you subtract 1 from whatever n was. So you can see how that works. So this power rule is used to do calculus, to calculate a derivative. So if this formula, if this is my total cost, and I want to find the marginal cost, take the derivative of the total cost as with respect to Q, it's going to be the derivative of a constant is 0, and the derivative of 6Q is 6. It's Q raised to the 1, so you're going to put that 1 in front, so 6 times 1, and then Q to the 0, which is 1. That's where we get 6. The second one, if this is my total revenue equation, again, remember what that is. It's the price times quantity. Price times quantity is a function of Q. It's going to be 500Q minus 4Q squared. Take the derivative of that using the power rule. It's going to be 500 minus 8, 2 times 4, times Q to 2 minus 1, so just a Q, so 8Q. So I've got my marginal cost equals 6, my marginal revenue equal to 500 minus 8Q. You set those equal to 0, and you can solve for Q equals 61.75 to maximize profit. And again, that's the number that we came up with right there. To maximize revenue, you just take the revenue function, 500 minus 8Q, and set it equal to 0. It solves for a little bit larger number. To maximize revenue, you're going to get a little bit bigger number. Okay, this was not an economic lecture. It was more of an Excel application to economics. Thanks.